So let's have a look at a couple of examples. Differentiate y equals e to the power of x minus x and find where the curve is stationary. Now, this is our key word here, stationary. A stationary curve means that it's not increasing or decreasing, it must be flat. So we're looking for, in other words, the place where the gradient of the curve is 0. Now, if we want the gradient of the curve to be 0, what we're saying is we want the gradient of the tangent to the curve to be 0. So we start by differentiating the function. So we know y, we can find now dy dx. Differentiating the first part, e to the power of x differentiates and becomes itself. And differentiating minus x just gives us minus 1. So here's a little formula that will help me find the gradient of the tangent to the curve, or in other words, the gradient of the curve, at any place I choose to investigate. Now, I'm not sure where that place is. That's what I need to find. But what I know is I'm looking for a place where the gradient is 0. dy dx is, in effect, the gradient. So I want to let dy dx equal 0, because that's where I'll find this flat part of the curve. So subbing in 0 for dy dx, I get this. Adding 1 to both sides, I get this. And now solving for x, I need to rewrite this as a log. E to the power of x is 1, so I write e to the power of x is 1. And I have my answer there. It happens at this point here, where x is equal to the log of 1 with a base of e. Now you can put that into your calculator to see what it is, or we can just literally write it like that. Now you should be thinking at this point, hold on, e to the power of something is 1. Anything to the power of 0 is 1, actually. So this whole thing equals 0, and you can confirm that by picking up your calculator and checking, but you might have already spotted it. So in fact, this happens when x is 0. Now we want to find where, and if we're looking at a Cartesian plane, knowing that x is 0 is helpful in a way. It tells us it's somewhere along here, but it'd be nice to find the exact place where it happens. So I want to think, when x is 0, what would y be? So I need to sub it in up here. So I write what I'm doing, when x equals 0, y equals, now I need to sub 0 in, e to the power of 0 is 1, minus 0, well 1 minus 0 is just 1. So I have the point x equals 0, y equals 1, which is here. So a nice way to finish these questions is to make sure you answer the question. Differentiate this and find where the curve is stationary. So I would answer by saying, therefore, the curve is stationary at 0, 1. And we've finished that one. Our next example asks us to find the equation of the tangent to the curve, underlining key points is helpful, and the curve is y equals 2 e to the power of x. And we want to find the equation when x equals 1. Important points. Then we need to show that this tangent passes through the origin. So we want the equation of a tangent. A tangent is a straight line. So we're looking for the equation of that straight line. We're going to need a few things. Obviously, if you're thinking ahead, you know that we're going to need to sub it into this formula. So think ahead. We're going to need a point, an x and a y. Well, we already know the x value. We'll need the y value that goes with that and sits on this curve. And we'll also need the gradient of the tangent at that point. So it doesn't make too much difference which thing you find first. I'm going to go for the y value first and say when x equals 1, y equals, well I need to sub 1 in here, e to the power of 1 is just e, so I'll have 2e. Okay, so I have the point 1, 2e already ready to go for my formula. Now I just need to find the gradient at that point. So I differentiate the curve, because differentiating gives me the gradient of the tangent and the curve itself. And to do that, I know that differentiating e to the power of x gives me e to the power of x, but the 2 stays out front, so the differentiation is exactly the same as the curve itself. Now I need to find what the gradient is when x is 1. So I write it like this, when x equals 1, dy dx is equal to, subbing 1 in there, I'm going to get 2e. Now I'm ready to use this formula. So y minus y1, my y1 is 2e, is equal to the gradient there, which is also 2e, outside of x minus my x value. Now we just need to tidy this up and make it look neat. So expanding out the brackets on this side, we have 2ex minus 2e, and then adding 2e to both sides, I have 2ex. Now if I had minus 2e, but I added 2e, then I'm left just with this. So this is the equation of my tangent. At that point I need to check what else needs doing, show that this tangent passes through the origin. Okay, continuing on, I'll continue on up here. When x equals 0, now I'm hoping that y will equal 0 in this curve here. So sub in x equals 0, we have 2 times e times 0, and that gives me 0. Therefore, the tangent passes through the origin. And I could write that neatly as 0, 0.